Welcome to our lesson where we will explain the use of maps in SCADA projects. When we select the map object, you can see many of its properties in the Advanced section. Using the Provider option, you can choose map services offered by different providers. This allows you to use various map views in your project. Let's continue using Google Maps. We can add markers to the map. As an example, I have added 2 markers. Let's add one more. We need to enter the coordinate information for the marker we added. For latitude, I enter 41. We can see our current location here. Let me update this value to 41.2. For the longitude value, let's enter 28.7. You can see that a new marker has been added over Arnevutkui on the map. For now, I will remove it. Displaying markers alone on the map may not always be sufficient. We usually expect some interaction when clicking on markers. For this, we use the Events tab. I had previously prepared a script for the onClick event. Let's take a look at it. In this code, we first need to determine which marker was clicked. While creating the markers, I assigned different names to them. I named one marker and the other marker 1. Using these names, we can distinguish which marker was clicked using a switch statement in the script. When the object named marker is clicked, we want the corresponding function to run. When marker 1 is clicked, a different function will be executed. This function opens our form called face screen. However, the opening parameters are different. When we click the first marker, this screen opens for pump 1. When we click marker 1, the same screen opens for pump 2. Now let's test this in Runtime. In the top left corner of the page, we can see the tags for pump 1 and pump 2. I click on the marker, and the related screen opens. We can also choose the opening position of the window. In this script, it was configured to open at coordinates 50 by 50. Now I will move it aside and click the other marker. We can see that it opens at a different position. This is because, for this selection, let me close these pages first. We defined it to open at coordinates 550. I am starting the runtime again. I clicked on the marker again. It is now working for pump 1. When we activate pump running, you can also see the running status on the main screen. When I click the other one, it opens with pump running already active. From here, we can also send commands to the main form by clicking pump run. For now, let's close these windows. In this lesson, we are reviewing the map module. We do not cover the face screen application and tag binding in this video. You can watch these topics in detail in our previous lesson. Now I am returning to the Screen Designer section. As an example, I had defined a polygon. You can see a triangular shape on the screen. This does not have to be a triangle only. Depending on how many points you define in the polygon, you can create squares, hexagons, or many other shapes. We enter the latitude and longitude values for each point here. I also use the visible condition feature here. When the tag named visible is true, the drawing will be displayed on the map. You can see a similar structure in the routes section. I configured it to be visible when the tag named visible2 is true. Defining 2 points was sufficient for the points section. If we want, we can define more points. This allows us to create different paths instead of a straight line. We could also use the visible property for markers. For example, you may want a marker to appear only when there is a fault at that station. We can also change the color of the marker here. For normal conditions, we can use a green marker, and for alarm conditions, different colors or sizes. Now let's see how the visible property of Polygon and routes works in Runtime. When I set the visible tags to true, you can see the objects on the map. The polygon and routes we added become visible. We can zoom using the mouse on the map. The map object stores previously opened locations in its cache and can be used even without an internet connection. I had defined a tag for the zoom level. Here we can see its value as 10. When I change the zoom level on the map, you can see that this value also changes. Similarly, we can send a set value to the zoom tag to adjust the map to the desired zoom level. These definitions here are related to the coordinate tags of marker 1. By changing these values, we can dynamically update the position of the marker. Let me also show you how I configured this. After selecting the map, all the markers I added are listed in the Properties section. By selecting the longitude tags here, we define their positions dynamically. This means we are controlling them through tags. We also selected the related tag here for zoom. There is another way to use the zoom tag. Let me show you that as well. Earlier, we added markers to the map. We also saw that clicking on markers opens new screens. Now let's add an object directly onto the map. First, let's add a panel. Then let's add some controls inside this panel. This panel will be fixed to the current coordinates of the map. Let's check this in Runtime. As you can see, when I drag the map, the panel moves together with the map. Let's assume we have many control objects. When we zoom out, these objects may overlap. Therefore, we can bind the visibility of this object to the zoom level. I select the panel object and click on the visible property. At the top, I select the zoom tag. And I configure it to be visible when the value is greater than a certain level. Now let's see how this works in Runtime. Since the zoom level is currently 10, the object is visible. When we zoom out, the zoom level becomes 9 and the object disappears. When we zoom in again, the object becomes visible. Thank you for watching this lesson.